Good morning, friends. I hope everyone is doing well. I request everyone to watch my videos in a sequence for better understanding. In the earlier video, we have discussed how to represent a pushdown automata. In this video, we will discuss how to construct a pushdown automata. I have taken a long ways, which in that long ways the strings are in the form of a power n, b power n, where n is greater than or equal to 1 over the input alphabets a comma b. N is greater than or equal to 1, so I can take n value is equal to 2. So a power 2, b power 2 is a string possible over this long ways, so I can write it as a b b. Now with this one, if you see that I can identify two points. The first point is that the number of a's should be equal to the number of b's. I have got 2a's and I got the 2b's. So if you see that any string which belongs to this long ways, the number of a's should be equal to the number of b's. And another thing is that it should be in the form of, once you see a a's, then if you start seeing a b, you should not find any a. Meaning is that this kind of string means the string a b, then after b you are seeing a. That is not possible. So the string does not belongs to the given long ways. So with these 2 points, we can understand that what are the strings which are belongs to this long ways. Now we have to do one thing. What is the thing? We need to count the number of a's, and then we need to count the number of b's, and we need to check whether the number of a's are equal to number of b's or not. If the number of a's and number of b's are equal, then only we can say that the string is belongs to this long ways. Otherwise, the string is not belongs to the given long ways. Now my point is that how can I count the number of a's and number of b's? We'll see. A, B, B. In pushdown automata, how can we do it is that we'll have a stack. In the stack, we'll have a bottom symbol Z. Now remember one thing. Whenever you have seen a input symbol A and the stack symbol is Z, I can say that the stack is empty. Then what I will do? I will push the A. Then again I have seen a and stack symbol is also A. Then again I will push it. Meaning is that I will push all the A's inside the stack. Okay. Once I see a B, one B I have seen. If the input symbol is B and the stack symbol is A, means the top of the stack you have a, then you have to pop that A. So meaning is that for one B you have found a 1A. Okay. Similarly, another B you have seen, you have to pop that A. Then if you pop all the A's, you will have the stack symbol bottom is Z. And input tape you will have epsilon, because when we are storing this string in the input tape, then at the end you have to keep the epsilon. So it will be useful for you to identify that the input string is completed. If you see a epsilon and the bottom of the stack is consists of Z, meaning is that only Z is there, then you can accept it. Means you should reach to the final state. How can you reach to the final state? If you accept the string, then you will reach to the final state. Are you able to understand? My point is that if you are seen an epsilon and if your bottom of the stack is Z, then you should accept the string. Now let me discuss with another example. When I can say that the number of A's are not equal to number of B's, I have found 3 A's and 2 B's. Now if you see that number of A's are not equal to number of B's, then this string does not belongs to this long ways, and my pushdown automata also should not accept. How I can say that? If it does not reach to the final state, then I can say that it is not acceptable pushdown automata. As we said earlier, whenever you see a input symbol A, all A's you need to push it. Okay. Then you have found a B. For the B, you will pop the A. And for the second B, you will pop the A. Now, if you delete the 2 A's or to pop the 2 A's, the stack will be represented like this. You will have A and Z and you have a epsilon. Now, when I will accept epsilon on Z, then only I will reach to the final state. But if you see that epsilon on A, I will not reach to the final state. If I does not reach to the final state, what I can say? The string is not accepted by the push down automata. Now with this introduction, we will construct the push down automata. Now listen carefully. Initially stack is empty. Okay, you have the bottom of the symbol Z. Okay, now you have A, B, B. This string you have to accept it because it belongs to long ways L. Now I am in the state Q0. Okay, I am looking at the input alphabet A and the stack symbol is Z. Input alphabet is A and stack symbol is Z. Then what should I do? I have to push it. How I will push it? A Z I will write. So then meaning is that on looking at the Z, I am pushing the A. So you are pushing the A. Now see, now your input pointer is pointing to this one. Now if you see any A's, A and the stack symbol is also A, what you have to do? You have to push them. Let me write like this so that you can understand. Okay, I am pushing that A. So by seeing the A and Z, you are pushing the A. Similarly, whenever you see an input symbol A and the stack symbol is A, that A also you are pushing it. Okay, so all A's are pushed. Now once you see a B, input symbol is B, and then the stack point symbol is A, top of the stack is A, then what should I do? With this B, I have to pop this A. How can I pop? If I write epsilon, then I can say that I am popping the element which is there in the top of the stack. What is the element which is there in the top of the stack? A. So that I am popping it. Okay. So here I am performing the push operation. Here I am performing the pop operation. So I am reaching to a state called Q1. Now if I see any B's, any number of B's as the input and the stack symbol is A, then what should I do? I have to pop it. Okay. So I will pop the any number of B's, whatever the number of B's are coming, I will pop the corresponding A's. Okay. Now once I do it, I will find a Z which is there in the bottom of the stack and my input will be with the epsilon. So if I look at the input symbol epsilon and bottom of the stack Z, I am seeing it, then what should I do? I have to keep it as Z only, because the same thing, empty bottom of the stack I will keep it. Then I will reach to the state Q2 and I will make it as a final state. Okay. Now this is the push down automata or deterministic push down automata. Why it is deterministic push down automata? By looking at a input alphabet A and Z, we are going to one state only. Similarly, by looking at the A and stack of the symbol is A, see these two are different. In this case, what we are saying, I am looking at the input alphabet A and stack symbol I am looking at is Z. Here it is, I am looking at the input alphabet A and stack I am looking at A. So these two are different. So you don't confuse, like here also it is going A, it is also going on A. It is non-deterministic, it is deterministic only. So this is the deterministic push down automata for the given long ways. We will check whether it is accepting all the strings which belongs to this long ways. Okay. Let me take AB. AB is the smallest string possible over this long ways. So what I will do, initially stack is consists of Z, which is the bottom of the stack. I am in the state Q0. I am in the state Q0. On looking the A, Q on A, what I am doing, I am pushing that A. Okay, I am pushing the A. Okay, now I am in the state Q0 only. Q0 on A, I am in the Q0 only. Now from Q0 on B, you are in the input symbol B. Now B on A, meaning is that your input symbol is B, stack symbol is A. What you are doing? You are popping that A. And which state you are in? You reach to the state called Q1. On looking at the B, you are reached to the state called Q1. Now Q1, your input symbol is epsilon, your stack symbol is Z, you are keeping it as Z, and you are reaching to the state called Q2. From Q1 on epsilon, you are reaching to a state called Q2, which is a final state or non-final state. As it is having double circle, I can say that it is a final state. So from the initial state, taking the input symbol, I am reaching to the state called final state. So I can say that the given string is accepted by the push down automata. Okay. Now we will take a counter example. Counter example means the string which does not belongs to given language. If it does not belongs to given language, what my push down automata should do? It should not accept it. Let's take that AAB. Okay, and I will end with an epsilon. This is the string is there in the input tape. Okay, initially stack is consists of only Z. Now I am in the state Q0. Q0 on A on Z, I have to push the A. And similarly Q0 on A on the stack symbol A, I have to push the A. So all A's I have pushed. Now I am in the state Q0. Now Q0 on B, what should I do? From Q0 on B and the stack symbol is A, you have to pop the A. So where you have reached? You have reached to the state called Q1. From Q1 you need to find anything is there called epsilon. What is the symbol you are looking? You are looking at the input symbol epsilon, and what is the stack symbol you are looking? A. You need to find whether you have any transition from Q1 on epsilon and A. You have epsilon on Z, you have a transition, but on epsilon on A, you don't have any move. So you cannot go anywhere. So you will be there in the state called Q1. So, or you can say that it is a dead configuration. So you are not able to reach to the final state. So I can say that the string is not accepted by the push down automata, which does not belongs to the given language. So what my push down automata is doing? What are the strings which belongs to the given language? It is accepting. What are the strings which does not belongs to this language? Is not accepting. So I can say that this is the correct push down automata for the given language. I hope you have understood how I have constructed the push down automata for a given language. If you have any doubts, feel free to ask it in the comment section. I will clear your doubts in less than 24 hours. Thank you so much.